Welcome to part 2 of the video, How to Build Your Own Personal Artificial Intelligence System. Based on the first video, we now try to optimize our output from the system. We call it the BERT-large edition. We just follow the same logic executing the code as we go along. The only difference now is that regarding the sentences, I have cleaned up the sentences a little bit. I have it now here. My file is called sentence new line Deloitte 21. But otherwise, we're going to do exactly the same as we did in part 1. And we end up with 1,793 sentences. And you can see that I eliminated sentences with just one word or sentences with just 2 words. And also the typical fill words we will or we might or regarding or whatsoever. I added about 200 stop words to the set of English stop words, and the sentence has been cleaned up a little bit for our artificial intelligence to not cope with those non-essential words in the sentence. So now we're going to choose, like in the first video, another car. We're going to choose BERT-large. And BERT-large has about 1.24 gigabyte size to download. I already downloaded it. And here we go. The sentences now are the same, more or less. But just now, here, we're gonna run BERT-large on our home PC. No NVIDIA graphic card, no CUDA cores. The work is done by a CPU. And to show you the performance of the CPU when you execute this code in PySpark 247, I insert a little window that you can see how the CPU and the memory are gonna behave when we execute this line of code. It's gonna take a little bit of time because, as you can see, a very professional code segment here. I noticed that the PC crashes immediately if I want to try to incorporate all 2000 sentences. Therefore, I have to split it up a little bit, put it back together, but otherwise there should be no problem at all executing this line of code. So CPU starts, you see in the insert, it's now at 96, 97%, and I come back to you when we are finished with this job. Here we are again, 3 minutes and 2 seconds later, the calculation is done. All the pre-trained embedding have been applied to our data frame, where we have text data frame. In the column text, we have all our sentences. And what we end up with is, just to notice, the memory, we did not exceed 17 gigabytes of memory for the calculation, and CPU is back to normal. What we end up with is another data frame, like in the first video, where each and every sentence has now an embedding. And just like before, we have a look about the dimensional embedding of each and every sentence, and we see here we have 1024 coordinate sets where each sentence is provided with this coordinate set. As we go through, save it to file, you can calculate again the cosine similarity of a given sentence of the set within the document. Here I choose sentence number 15, like in the old example of video 1. Enterprise technology, spotlight importance, align corporate technology strategy. You see some fill words are missing now in the sentence, but the returning sentences from our personal artificial intelligence system are not now much more spot on if you compare it to the thematic content of the sentence. So switching to BERT-large with 1.24 gigabyte does provide here an improvement. If we take another sentence, and it's the identical sentence from video 1, Trust Machine Learning University, and we apply the embedding to this sentence and we compare it and ask the system, hey, what are the sentences within the system that are most similar to this sentence that I just told you? We get the result that's after 26 seconds. That's for my sentence, Trust Machine Learning University. Oops. Close the sentence, tech scales trust, analytics development layer, invested technology like advanced analytics cloud ERP system. Interesting. Okay. We apply UMAP for dimensionality reduction. We do it in 5 dimensions. We get an embedding for each and every sentence. Now, with a 5-dimensional coordinate system set, we're going to cluster it again. We leave the minimum cluster size at 60, minimum sample size on 5, like in the first example. And let's check how many clusters we end up with this time. This time we have 9 clusters again, like in the first example. This is exactly the amount of segments Deloitte TechTrends2021 has in the edition for human readers. We have again the cluster of -1, where all the noise sentences are put together. Cluster -1 has 463 sentences. The system could not decide where to assign those specific sentences to the other clusters. And you see here cluster 2 has 347 sentences. Please note that now the number of the cluster does not coincide with the number of the cluster from video 1. We try to get a visualization of our results to see if we still have some outliers in a 3-dimensional representation of the data cloud. Again, remember, we operate in a topological space. We use especially UMAP, incorporating some mathematical algorithms and mathematical theorems from algebraic topology. Sorry. And we end up with a sentence. Sentence belongs to the cluster number 2 with label 2. And for each sentence, we have a coordinate set x, y, and z. And now it is simple to just start the 3D visualization. I apply network X, matplotlib, pyplot, or plotly, and we end up with a visualization. And yeah, where we have a point cloud where there are no visible significant outlier. It looks like the system now has done a much better job with BERT-large, segmenting, embedding the sentences, clustering the sentences, and reduce the dimension from 1024 to 3-dimensional, set for a better visualization. Again, like in video 1, we're going to ask us, okay, if these are in yellow, each dot is a sentence, and it's color encoded, so all the sentences, let's say for example of this cluster indicated with yellow, what are the top words, what are the top bigrams of all the sentences in this yellow cluster, or maybe what are the trigrams of all the sentences in the different clusters. We execute again this beautiful code, again by Martin Grotendorst. Have a look at his GitHub repository. And we end up with, including category -1, the answer of our personal artificial system. And it is now we have clusters 0 to 8. So we have 9 clusters. Our fine-tuning of UMAP, our fine-tuning of the cluster algorithm resulted that we managed to come up with 9 clusters that we were looking for. But be aware, we manually tuned the system to receive 9 clusters. The magnitude indicates how many sentences are or constitute each cluster. And here we have the top words, the top bigrams, the most important trigrams of this specific cluster. Supply chains, plural, supply chain, singular, cost center, business strategy, long-term, supply networks, core modernization, that sounds good. Remote work, digital workplace, ways of working, work-life, balanced team performance, remote worker, working at home. Yeah, sounds much more consistent than in video 1. Zero trust, here cybersecurity topic, security posture, zero trust approach, trust architecture, zero trust architectures. This sounds really much better than the first time. Real-time, cloud-based, edge computing, unstructured data, legacy systems, cloud-based data. Yes, machine learning. Yes, it's also what we are looking for. Code supply chain. Here we have another supply chain. And again, as I already told you in video 1, BERT is word piece sensitive. It does the embedding on word pieces based on the pre-training set. And since if you have two sentences, the words are sensitive to the content of the sentence, therefore we have supply chain and supply chain. It's not a duplicate, but here the system analyzed that supply chain in this cluster 0, where we have 78 sentences, the meaning of supply chain is a different meaning than the meaning of supply chain in a sentence in cluster number 2. And if you compare now our 7 clusters with the top words or the top wording in the cluster with the 9 human-readable segmentation of the document, you will find out that this fit now is much better than in video 1, where we had just BERT base. We did not clean our input sentences rigorously enough. We had a lot of fill words, a lot of multiple fill words. But now, if we look at these sentences, our personal artificial intelligence system improved quite a lot. And for video number 3, our question remains, how can we improve it even further? On our home PC, running a Windows 10 Home Edition on Jupyter Lab and a special environment SparkNLP 247. Thank you.